What if an AI could answer questions about the latest information without retraining? The problem is, LLMs can sound incredibly confident, even when they are completely wrong. So, how do we make AI answers depend on real evidence? That's where grounding comes in. In this video, we'll see what grounding is, how it reduces hallucinations, and how it connects to RAG, search, and tools, and how we evaluate whether an answer is actually grounded. Here's the core problem with LLMs. They generate text from patterns learned during training. They don't inherently know whether what they are saying is actually true. That means a model can produce an answer that sounds perfect but has absolutely no evidence behind it. Grounding changes this. Instead of asking the model to rely only on what it learned during training, we connect its answer to real external evidence. So the difference is simple. Ungrounded answers can be plausible. Grounded answers are based on evidence. And this is why hallucination happens. An LLM doesn't have a built in fact checker saying, wait, is this actually true? It predicts what text is likely to come next. So it can hallucinate facts, numbers, citations, even API responses. And there's another problem. The world keeps changing, while the model's training data has a cutoff. The result? Fluent doesn't necessarily mean correct. Grounding gives the model additional information it can use to produce a more reliable answer. But here's an important catch. Grounding isn't magic. Imagine we retrieve the perfect document. The model can still misread it, ignore important information, or go beyond what the evidence actually says. So there are really two separate failure points: retrieval quality and generation quality. Retrieve the wrong evidence, we can get the wrong answer. And even with the right evidence, the model can still hallucinate. Grounding reduces the odds, but it doesn't eliminate them. So, where does this evidence actually come from? Pretty much anywhere you can get reliable external information. It could be documents, databases, web search, APIs, structured data, enterprise knowledge bases, code repositories, or even live sensor data. The important idea is that grounding isn't one specific technique. It's the broader concept of connecting an AI system to external evidence. And this is where an important distinction comes in. RAG is grounding, but grounding is much bigger than RAG. You'll often hear people use grounding and RAG almost interchangeably, but they are not the same thing. RAG, or retrieval augmented generation, is one type of grounding an AI system. You can also ground a model using web search, database queries, API calls, tool use, or an enterprise knowledge base. So think of it this way: grounding is the umbrella, RAG is one branch underneath it. That distinction comes really important when designing real world AI systems. Let's look at a typical RAG style retrieval pipeline. First, we take documents and split them into smaller chunks. Those chunks are converted into embeddings and stored in a vector database. When a user asks a question, the system searches for the most familiar pieces of information. That relevant context is then passed to the LLM. So the flow is documents, then chunking, then embeddings, then vector DB, then comes query, then comes similarity search, and after that relevant context, and finally to the LLM. The goal is simple: give the model the right context, not everything. But not every question should be answered using documents. What if I ask for today's stock price? A document might contain yesterday's price, but that's not enough. Instead, the model can call a tool such as a stock API, retrieve the current price, and then use that live result to generate the answer. The same idea works with weather APIs, calculators, SQL databases, search engines, and code execution. So, tool use is another form of grounding, grounding through action rather than retrieval. Here's another misconception: more context doesn't automatically mean better grounding. You could give an LLM 100 pages of information and still get a bad answer. Why? Because grounding quality depends on three things: reliability. Is the source trustworthy? Relevance. Does this actually answer the question? And coverage. Is there enough evidence to support the answer? So don't focus on stuffing more information into the context. Focus on getting relevant, reliable, and sufficient evidence. Now we have the evidence, but there's still one critical step left: generation. The model has to actually use the evidence when producing its answer. For example, if a company report says its 2025 revenue was $10 billion, a grounded response should reflect that information and, where possible, identify the source. That's what makes the answer evidence based, attributable, and citable. So, retrieving evidence is only half the job. The other half is making sure the model faithfully uses that evidence. So, how do we test whether the model actually followed the evidence? One approach is faithfulness evaluation. Take the claims made by the model and compare each one against the retrieved evidence. For example, the source might say the company has 500 employees. If the model says it has 500 employees, that's supported. But if it suddenly adds that the company has offices in 12 countries and the evidence never said that, that's an unsupported claim. So we are essentially asking which parts of this answer are actually supported by the evidence. Even a well designed grounding system can fail. Maybe retrieval finds the wrong document, maybe the information simply isn't available, maybe the source is outdated, maybe two sources contain conflicting information, or maybe the model receives the correct evidence but ignores it. These are five major failure modes: bad retrieval, missing information, outdated sources, conflicting evidence, and ignored evidence. The key lesson is that good grounding architecture doesn't assume everything will work perfectly, it anticipates failure. And this brings us to the bigger picture. Modern AI systems can combine multiple grounding mechanisms. RAG can retrieve documents, web search can retrieve information from the internet, tools and APIs can provide live or structured data. All of these sources can feed information into the same LLM. But remember, the final answer is only as grounded as the weakest link in that chain. RAG retrieves, tools retrieve or generate. Grounding is the broader idea of making answers depend on reliable evidence. And that's the foundation behind many modern AI systems. If you found this video helpful, like the video, share it with someone learning AI, and subscribe to the channel for more deep dives into modern AI systems. Thanks for watching, and I'll see you in the next one.